In the last video, we solved simultaneous equations by the elimination method. In this video, we're going to solve simultaneous equations by substitution. So our first question is the first equation, 5x minus 2y equals 16. And the second equation is x minus y equals 2. Now the trick with the substitution method is to rearrange one of the two equations into the form x equals or y equals. We make one of the variables the subject of the equation. So I'm going to take equation 2 and I'm going to add y to both sides. So by adding y to both sides, it cancels the minus y here, and we're going to get 2 plus y. Now we know what x is, we can substitute this in to our first equation. So substituting 2 into 1, we're going to have 5 lots of, instead of x, we've got 2 plus y. Subtract 2y equals 16. Now we'd go through the normal method of solving this. We multiply out the brackets. 10 plus 5y minus 2y is 16. So the 5y subtract 2y is 3y. 10 plus 3y equals 16. Subtract 10 from both sides, 3y equals 6, and then divide by 3, y equals 2. But remember, we need a value for x and a value for y. So we're going to substitute this back into one of our formulas. And I'm going to do the second because it's the most simple. So x subtract 2 equals 2. We add 2 to both sides, x equals 4. And that is our pair of solutions. Now, the substitution method works particularly well when we have squared or cubed or any power of our variable. So our second equation, we're going to have for the first one, x squared minus 2y squared equals 7. And for the second one, x plus y equals 8. And we're going to rearrange the second equation in this example. We're going to subtract y from both sides, so x equals 8 minus y. So we're going to take 2 and substitute it into 1. And this gives us, instead of x squared, 8 minus y squared, subtract 2y squared equals 7. I'm going to simplify this and get it to a state where we've got a positive y squared. Y squared plus 16y minus 57 equals 0. We can solve this via factorising. Y subtract 3, y plus 19. Now one of these brackets has got to equal 0, so y minus 3 has got to equal 0, so y equals 3, or y plus 19 has got to equal 0, so y equals negative 19. So we've got 2 values for y. And this happens because we've got a y squared and an x squared. So we're going to substitute this in, and I'm going to substitute it into the second equation because it's the easiest. So x plus 3 equals 8, so x equals 5, or x plus minus 19 equals 8, so x equals 27. Now, with this, we need to pair our solutions together. So when we had y equals 3, this goes with x equals 5, and that is one set of solutions. And when y equaled minus 19, x equal 27, and that's our second pair of solutions. We need to work out both.